Welcome back. A small recap of what we have discussed in the small introduction earlier. An algorithm is a sequence of unambiguous instructions for solving the problem. That's for obtaining a required output for any legitimate input in a finite amount of time. So every problem is solved by using some algorithm. Algorithms are written for computer, and algorithms used to have some input, and the computer produces an output based on the input what is given to an algorithm. So these are the important points that we have discussed in the introduction video. Non-ambiguous requirement, the range of input. Same algorithm can be represented in different ways. Several algorithms for solving the same problem, and algorithms for the same problem can be based on very different ideas, and it can solve the problem with a dramatically different speeds. Let's see the three different methods for finding the GCD and then writing an algorithm for each and every method of what we have discussed here. GCD of two numbers can be found by using a Euclid algorithm or consecutive integers checking algorithm or finding the prime factorization. The GCD of two integers with the different ways is the GCD of m comma n is equal to GCD of n comma m mod n. That means it's applied repetitively until m mod n is equal to 0. Since GCD of m comma o m comma 0 is equal to m, the loss value of m is also the GCD of the initial m and n. So the algorithm steps are like this. If n is equal to 0, return the value of m as an answer and stop. Otherwise, we proceed to the step 2. In step 2, we divide m by n and assign the value of the remainder to r. In step 3, assign the value of n to m and the value of r to n and go to the step 1. The second method is a consecutive integers checking method. Assign the value of minimum of m comma n to a temporary variable t. Divide m by t. If the remainder of this division is 0, go to the step 3, otherwise go to step 4. Divide n by t. If the remainder of this division is 0, return the value t as an answer and stop. Otherwise, proceed to the step 4. Decrease the value of the temp variable by 1 and iterate to the step 2. The third procedure, which very commonly we would have learned it in school. Find the prime factors of m, find the prime factors of n, and identify the common factors of the two prime expansions what we have done in the previous steps. If p is a common factor occurring in both pm times and pn times, it should be repeatedly, we have to take the minimum number of times. What is the minimum number of times repeated in both the factors? Compute the product of all the common factors and return that value as a GCD of the given numbers. The fundamentals of algorithmic problem solving can be understood easily with this diagram. To understand the problem, the decision is taken on design an algorithm and prove its correctness, and we analyze the algorithm Then finally we code for an algorithm. So to understand the problem, we have to analyze and design an algorithm. It's a stepwise refined procedure. Then we have to prove its correctness, and we have to analyze it and then code. So DPAC, you remember, design, prove, analyze, code. DPAC. What's an understanding the problem? An input on algorithm specifies an instance of the problem the algorithm solves. It's also important to specify exactly the range of instances the algorithm needs to handle. Before this, we have to clearly understand the problem and clarify the doubts after reading the problem's description. Correct algorithm should work for all possible inputs. So input is very important for an algorithm. So if you have given the right input and if you have understood the problem clearly, it can lead to the right solution. Next is ascertaining the capabilities of a computational device. The essence of von Neumann architecture is captured by RAM, random access memory, the main memory. Here only the instructions are stored and executed. The instructions are executed one after the other. The algorithms designed to be executed on such machines are called as a sequential algorithms. The algorithms that execute on two processors at the same times, which are called as a parallel algorithms. So the parallel algorithms has the capability of executing the operations concurrently, not sequentially, not one by one. How to choose between the exact and appropriate problem solving? There are three issues to choose an approximation algorithm. First is there are certain problems like extracting square roots, solving nonlinear equations. Secondly, if the problem is complicated, it slows the operations. So whenever we try to discuss about the complicated problems, the trivial example that we take is the traveling salesman problem, finding the shortest path between the source and the destination to reach the travel by a salesman to reduce the traveling cost. Third, this algorithm can be a part of a more sophisticated algorithm that solves the problem exactly. The next important step is the deciding on data structures. The data structures are the places where we store the data to give it to an algorithm and store the output of an algorithm. Algorithm plus data structures makes the programs. Next is an algorithm design techniques. It's a general approach for solving the problems, variety of problems. Basically, it's applicable, particularly in computing field. Learning these techniques are important for two reasons. One is they provide a guidance for designing for new problems, and second is algorithms are the cornerstones of the computer science. Methods of specifying an algorithm. There are two different methods. One is pseudocode, another one is a flowchart. Then there's another one more tool is there which is called as a structured English. But they are quite synonymous to pseudocode and algorithms. Pseudocodes are the mixture of both the natural language as well as the programming constructs. Flowchart is a diagrammatic representation which tries to connect through the geometric shapes for the descriptions of the steps that's followed in the algorithms. Proving an algorithm's correctness. The correctness has to be proved for every algorithm. To prove that algorithm gives the required result for every legitimate input in a finite amount of time. So that's the reason we need to prove an algorithm. We need to correct an algorithm. To analyze an algorithm, there are two kinds of algorithmic efficiency. One is time efficiency, another one is a space efficiency. Time and efficiency means the execution time. Space efficiency tells the amount of memory that it takes for storing, processing, and producing the result of an algorithm. Another desirable characteristics is the simplicity and generality. Next, coding an algorithm. Programming the algorithm by using some programming language. Formal verification is done for all small programs. Validity is done through testing and debugging. These are all the common problems that we will be discussing in this chapter: sorting, searching, string processing, graph problems, combinatorial problems, geometric problems, numerical problems. These are all the different types of the problems that we generally talk about, and for which various algorithms are required to do it efficiently in computing. These are the fundamental data structures that we talk about in analysis and design of algorithms. The linear data structures, graphs, trees, sets, and dictionaries. The linear data structures are arrays, strings, lists, linked lists, stacks, and queues. In graph representation, we may have a weighted graphs as well as paths and cycles. In trees, rooted as well as in ordered trees. In ordered tree, it can be a binary search tree, multi-way search tree, first child, next sibling representations. Sets and dictionaries. Say universal set, multi-set, or back dictionary. So this is what the first chapter that we are talking about. I hope this gave a good introduction about an algorithm, what algorithmic complexities that we are talking about, fundamentals of algorithmic problem solving, and what are the various steps of designing and analyzing an algorithm, and what are the various important problem types that we talk about in terms of computing. So we talk about this types in detail in the next video as well. Thank you.